Hello, everybody. Sankey organizers and sponsors, it's just been my great pleasure to be here this week. Kamsahamnida. Now the rest of my speech will be in English, so sorry, that's all you got. It was really nice to have Dr. Choi and Mr. Park present first, because what you saw from them was the value and the application of standards to enable business, to enable economy. So we understand the value now. What I want to do today is talk to you a little bit more about how we drive those requirements to create the standards, illustrate with a few standards, and then maybe give you a preview of what's coming. So again, I'm Scott Simmons, Chief Standards Officer with OGC. Those of you not familiar with OGC, we're an international consortium dedicated to making location or geospatial information fair, findable, accessible, interoperable, and reusable. That is our mission. We do that primarily through the development of standards, but also through applied research and development projects to test those standards and ensure that they meet real-world requirements. We have almost 600 member organizations spread around the world in all but one of the inhabited time zones, so very good representation globally. About 40% of our members are commercial, the other half evenly split between academia and government. And this brings great value. Having these commercial members ensures that those standards and practices we develop are viable, survivable in the commercial marketplace. If you write a standard that's not used, you haven't written a standard, you've just made some paper, as Dr. Choi said, sitting on a desk. So who and what drive these requirements? Well, inside OGC, if we're going to work just in our environment, and I'll be a little selfish in this description, we divide the task amongst two types of groups. We have working groups, known as domain working groups, that focus on that requirements gathering, identifying needs, understanding how standards or other practices are used in the community, and they work in an open environment. They're open to the public. They may have hundreds of members, and they have sessions much like this, an open exchange of information. If that working group thinks there is an opportunity to standardize, then we move the work over to a standards working group where we can focus on developing that standard, building it out, and getting it approved, much like the process for those of you here for the ISO meetings. But equally important is our coordination with our partners. There's a number of organizations, be they standards bodies or industry associations, that we work very closely with. And that's perhaps the most important part of my job, is to come to events like the ISO TC 211 meeting and understand those requirements that we mutually need to work together on. An example, the aviation community writes standards to exchange flight paths for aircrafts. We don't write that standard, but we write the little piece that tells the flight path where it is with reference to the ground. The other pieces are outside our expertise. And in ISO, we work very closely with a number of committees, primarily ISO TC 211. Our organizations were founded the same year, and we coordinate very closely on a number of topics, but many others. I mentioned earlier we do applied research. This is very important and increasingly so in our standardization. Again, we don't want a standard to be a piece of paper on a desk. We want that standard to be used. What better way than while developing the standard to test it in real time and see if it's addressing the needs? And so what we have on the left is an innovation cycle where we research ideas for standardization. We bring those to the right side to our standardization cycle, create standards, and then test them in that same environment all over again. And we have this continuum of development. In the end, you've proven implementations, you've proven the ability for the community to integrate, to work together with these standards, and if we do it right, you prove your standard works in a much larger ecosystem, such as others from ISO, such as others from other standards bodies. And so this is very important to our work at all times. Sometimes we do this through code sprints and other things, but regardless, it's an innovative way to develop standards, and it ensures your standards are meaningful. So that's a bit about how we do it. Well, what's the result? A few just common standards. Some of these may be new to you, some of these may seem obvious, but believe it or not, everything needs a standard. OGC has a lot of standards. There's a famous phrase, the great thing about standards is there's so many to choose from. And that's actually the case for us. We have over 150 published standards, but they all sit in an architecture that's tiered to go from that collection of information at the bottom through modeling and encoding the data in the middle and to deploy it to the end user via services, containers, or discoverability options. And so you just pick and choose your path through this diagram. Pick those standards that address your problem. They're discrete. In theory, they're easy to implement. I know they're not always easy to implement, but some of them are. But you pick those you need, you bolt them together, and you create your solution. You've created a ship out of a whole bunch of little parts. The simplest of all, the first OGC standard ever, 25 years old this year, is Simple Features, also published in ISO. Simple Features does what's on the right. It's just a really easy way to describe vector or feature data that's geospatial, points, lines, polygons, that really easy stuff. Again, seems incredibly simple, but if you don't describe it the same way, it doesn't work the same way electronically on a computer. So this standard very simply describes simple features. It hasn't changed at all in 25 years. There's no reason it needs to. Yes, I put a diagram on there for the geeks in the audience, but it's a really simple thing. It's in every database and underlies every other vector data set you ever use. We have a number of web service standards. 2 of these are also published jointly with ISO. So these are the legacy web map service, web feature service, and others that bring your spatial data to the web. They've been around a long time as well. The web map service started in the year 2000. These are heavily used by governments to this day. There are more than 500,000 servers deploying web map service around the globe at this time. And so here's an example from the UK Meteorological Office about all the different types of weather data that are served using this family of standards. But they're evolving. And so we're now looking at use of APIs to bring the same information to you. Let's take a story. We have some data. You want that data just to be visible on your mobile device. You want to tile up the information so it's really simple to see on your device. You wrap it in something referred to as our common OGC API, attach the tiles API to it, and the data works with your phone. Now you have that same data, but your user wants to make queries against it, and it's sort of some feature data. So add the features component to it and add the query language. Same data again, you need to support other coordinate reference systems. Just bolt on the coordinate reference system piece. And you see this pattern's quite simple. So finally, if you're someone dealing with an emergency management issue, you need every bit of that information in all those different ways. Your same data, you just bolt all these other pieces onto it. You pick and choose those pieces you need, and you provide a solution to your users. That's the fashion where standards are going now. That's what we're all needing your input as a community to help drive what are those modules, what are those pieces we need to ensure that the standards we develop are applicable to our problem set and are simple enough to put together to solve just the problem you need. You no longer should have to read a 2,400-page document, which I'm not kidding, there's an OGC standard that's 2,400 pages long, to understand how to describe three-dimensional data for simulation of military exercises. Really great standard, but that's not what anyone needs now. What you need are 10, 12-page documents that do the same thing. And that's really where we're trying to go, and this is the example of where that's going. There was a mention in the earlier session about environmental data retrieval. So the U.S. National Weather Service uses this API and puts just the right pieces together to give all the different layers of forecast information for weather over the continental United States. Now, your standard data isn't always available on a computer. Sometimes all you have is this. Sorry, it's not Samsung, so I feel kind of guilty, but that's all you've got. Well, we have something referred to as the geopackage. Geopackage takes all that kind of information I've just described to you and puts it together in a small little database that's deployable to people who have mobile devices or to people who have limited connectivity. A really important problem. This is very heavily used by defense organizations around the world because when people go off to fight a war, you can't count on mobile telephone service, right? Cell service is pitiful in these environments, so they need ways to have portable data. The underlying functions built on standard ISO and OGC standards that are then bolted together into this very clever little package. We also have a 3D standard that got mentioned a lot in earlier sessions today, City GML. Not only does it describe 3D buildings in various degrees of detail, but you can do very sophisticated modeling with it. A great example, Berlin, Germany, models the entire city in City GML and then performs energy consumption analysis and energy generation analysis. Where do I put my solar panels? How close are they to the people who need heat or cooling? And right here in Korea, developed indoor GML, so a standard for not just indoor mapping and modeling, but also navigation of indoor spaces. A very complicated problem if you think about it. When you go into an indoor space and you're walking on two legs versus you go in a wheelchair, you have radically different constraints about how you can move through that space. And this standard lets you divide up spaces into these very discrete pieces that you can navigate in and also give you more information about that space. And it integrates with City GML so that you can have a common modeling environment. This is just some of the most stunning work we've had in OGC and is now expanding to new work in ISO to describe in a common way indoor spaces that is applicable and more broadly used than just this navigation standard. And we do a lot of work with sensors. So when looking at mobile environments, navigation, routing, you are collecting information on your device. There's a GPS chip in here. It's a sensor. It's getting information. There's also something doing inertia. There's something doing humidity, et cetera. All of those sensors need to be integrated. They're very low power. They're very, very simple in what they do. They don't need a lot of bandwidth, so we have written some very lightweight sensor standards to put those together. And this is an example from Chinese Taipei of using sensor integration for disaster management, looking at flood and flood indicators across the island, depending on major, say, typhoon events, and how do you understand when your sewers are going to overflow into your streets. And using sophisticated sensors like surveillance cameras with automated sensing, or very simple sensors like water level gauges. So those are some of the ones in common use. Well, what are we doing now? And again, where can we use help from this community? And what am I gathering this week? So let's talk about the future. Where are we headed? Artificial intelligence comes up time and time again. You cannot go more than 10 inches or turn one page in a document anywhere and not see AI somewhere. Well, we have a domain working group talking about the problems of artificial intelligence and geoinformatics. That's a lot of words. But where do we need to identify these standards targets to address artificial intelligence? We know we cannot standardize the algorithm. That is what everyone's specialty is. But we can do a lot of things around the algorithm for spatial importance. So we have a new candidate standard that actually will go out to vote in just a few days for a training data markup language. So at least when we train our artificial intelligence algorithms, we have a common language to train them and a common language to test. It's these little pieces of the problem that we can solve, small discrete standards. And it's a fairly simple model. You saw that. But it's being used now. So a standard that has not even got out to vote is already deployed in numerous instances. And that's a new model as well, where we don't just write a standard from scratch. We actually test it while writing it and deploy it first. We're working jointly with ISO TC211 on new standardization for analysis-ready data. How do you prepare your information? Not just your satellite images to perform analysis, but all types of spatial information. We'll start with satellite images because that's where the expertise lies, but we will standardize any way to get your information ready for analysis. And that includes this concept of decision-ready data. I have to make a decision based on data. That decision is based on analysis. That analysis is based on the data. How do we chain all of that together? It's really important. And we have a number of parts for that, and we're going to focus these on a variety of scenarios. We have a new standard for publication and subscription, so syndication of data that's underway with a new API so that you can get weather data real time on your device, spatially located to where you are. And we're working on a new tiles code sprint to test this with updating tile information. And then finally, back to our roots. How do we all get in spatial? It was this, right? So we all had maps. We all love maps. This is why all of us got into this, paper maps. Well, all those maps moving from paper to computer rely on portrayal standards, standards to depict the information, and the entire suite of portrayal standards being used in the community is currently under a significant and major update. And so we have an entire workshop dedicated to this in 3 weeks in the United States if you want to attend, and a further meeting in Cape Town, South Africa later in the year. And with that, thank you very much for your time, and I look forward to talking with everyone later.